Welcome to Reasons to Believe, the television show where we explore new reasons to believe in Christ as Creator, Lord, and Savior, and for the accuracy and reliability of the words of the Bible and the Christian faith. And today we're going to be starting a new series where we look at the universe from planet Earth out to the edge of the universe. It's a new production of our Journey Towards Creation television documentary. But I wanted to just thank all of you who have written in letters giving us suggestions for future episodes and comments and feedback on this program. And I have with me here today our staff physicist, Dr. David Rogstad.
Good to be here.
Dave, thank you for joining me on this discussion of our journey to the edge of the universe. But I wanted you to just give us a little bit of the feedback we've been receiving.
Yeah, let me read this letter. This is from Kathy. It's an email, so I don't know where she is actually from. But she says, I'm an author of 6 books of children's fiction, a series. And she says, as one writer to another, I would like to thank you for letting the Lord write through you as surely as he did through Moses. So there's quite a remarkable statement. She says, as a Christian, I've always been deeply troubled by the discrepancies between what I knew from the age of the universe and the nature of our planet and the account that we find in Genesis. When someone told me about the fingerprint of God, I read it, and now I read Genesis, and I marvel at how the Lord inspired Moses to write a perfect scientific account of Earth's life stages. So that was a very encouraging letter. And
very encouraging, and I appreciate the fact that she picked up on, Moses wasn't writing in the 20th century.
That's right.
He was writing 3,500 years ago. And it'd be one thing for someone like myself to put together this account because, we have all
we,
these...
of course, have all the information.
We have all the information, but for Moses to do it, that's clear proof that he was uniquely inspired.
That's right.
By the Holy Spirit.
Yeah, it's really an amazing account considering that it covers, as you've pointed out a number of times, only a page in the Bible, and yet has an account that is understandable by the average person, and at the same time is scientifically accurate.
And understandable by people who lived over 3,500 years.
Yes.
I mean, a one-page summary. I mean, that really is a miracle when you think about it in that context. I appreciate the fact she picked up on that. And,
yes.
But yeah, her generous comments towards us are also much appreciated. Well, today what we want to do is give you a start on what we call Journey Toward Creation. And we've shown this television documentary in the past on the Trinity Broadcasting Network. In fact, I think it's been shown twice on the primetime TBN network. But what we've done over the past couple of years is to it's basically an update of that Journey Toward Creation documentary. And thanks to new discoveries that have been made, we can make a much stronger case today than we could 5 years ago when we showed this on television. And also, we recognize that there was such significant new information that we made this documentary a little longer. Instead of 57, 58 minutes, it's now 70 minutes. And so what we want to do is just show you this piece by piece in the next several episodes. So right now we're going to show you the first clip.
We are passengers on a controlled and purposeful explosion. As if we're microbes riding on a piece of shrapnel from an exploding grenade. All of the universe's matter and energy, even space and time, came into existence in a single moment. But far from a chaotic explosion, this initial blast seems to have been finely tuned, as if it has been designed to benefit us and our tiny planet. Today, our knowledge of the heavens and the earth and the forces influencing them is greater than that of all previous generations combined. and our sense of wonder grows with each new revelation. Astronomer Hugh Ross will be our guide as we tour the universe. We'll travel outward in space and backward in time. We'll marvel at the power and the intricate design around us. And we'll gain a clearer picture of our cosmic context, our place in the physical universe, and in the spiritual realm that encompasses it.
Ever since I was a young child, I wanted to know more about the stars and galaxies, to see them up close and unlock their mysteries. Strangely enough, starlight and galaxy light are our greatest tools for unlocking the mysteries of creation. This is the Keck Observatory, the world's largest optical telescopes. Together, these two telescopes have 8 times the collecting area of the Mount Palomar telescope and more than 30 times that of the Hubble Space Telescope. The Keck telescope has 36 independently driven mirrors. Computers control the movement of these mirrors so that they work in sync as one gigantic 400-inch telescope. It's also very precisely figured down to a molecule's thickness. With sensitive light and radio wave gathering instruments like this, we can look out billions of light years into space to the very limits of the cosmos itself. But as we look out into space, we're also looking back in time. This is where astronomy is unique among the sciences, because it alone directly observes the past. As a matter of fact, astronomers are always observing the past. Light waves, radio waves, and all other kinds of electromagnetic waves may seem to reach us instantaneously, but they don't. They seem to because they travel so fast. Light speeds through space at 186,000 miles per second, fast enough to circle the globe 7.5 times in a second. When we look at the sun, 93 million miles away, we're seeing what it looked like when the light left it about 8 minutes ago. Likewise, when we look at the moon, we're seeing it as it appeared about 2 seconds ago. When we look out to the stars, we're seeing them as they were thousands, millions, even billions of years ago. The farther away an object is, the longer ago its light began its trip through space. The distance light covers in a year, about 6 trillion miles, we call a light year. Light years offer a more convenient method for indicating vast distances. The most distant galaxies ever detected by astronomers are about 13 billion light years away. That means the light from those galaxies took 13 billion years to arrive on Earth. As we gaze at this galaxy, we're looking back in time at how it appeared 13 billion years ago. The distance back to the dawn of the cosmos is finite but enormous. So let's scale it down to a manageable or imaginable distance we can more easily understand. Let's compare it to the distance between the Space Needle here in Seattle and the Empire State Building in New York City, about 2,500 miles. The Space Needle can represent our current position in time, and the Empire State Building the beginning of time. As we travel out into space and back in time, we'll check our progress on this landmark to landmark cross-country map. Our time machine will be a telescope. We will peer back in time, all the way back to the moments just after the creation event, almost 14 billion years ago. And as we travel back in time, we'll do some sightseeing along the way and explore this question. Is the Earth a common rocky planet, possibly one among many, maybe even thousands of life support sites? Or is it one of a kind, uniquely fit for humans? Now we're ready to start our journey back in time. We'll begin with our nearest neighbor in space, a cosmic hitchhiker only 2 seconds away, the Moon. Our Moon has long mystified astronomers. It is so large relative to Earth that the Earth and Moon together are often classified as a double planet system. But studies of gravity show that no such double planet can form out of a single gas and dust cloud so close to a star as we are to the Sun. The Moon must have formed later through some unusual process. Moon exploration enabled us to confirm that lunar rocks differ chemically from Earth rocks. Through study of lunar rocks' radioactive decay, researchers discovered that the Moon is in fact nearly 100 million years younger than the Earth. In the 1990s, a theory explaining the Moon's existence gained wide acceptance in the scientific community. According to this theory, an object the size of Mars crashed into the newly forming Earth about 4.5 billion years ago. It struck at high speed, more than 200,000 miles per hour. Most of the object's mass was absorbed by the Earth, but this collision also sent up a huge cloud of dust and rocky fragments all around the Earth. In time, gravity pulled those fragments together into one solid body, the Moon. The Earth, meanwhile, lost its entire atmosphere, and a new, much thinner one began to form from gases released by Earth's crustal material. Such a collision may seem a disaster, but it proved just the opposite. It set in motion certain alterations to Earth's features that eventually made this planet a uniquely suitable site for life. The odds against a collision benefiting the eventual support of human life are staggering. The planet colliding with the Earth would need to be the right size, moving at the right velocity, striking at the right angle, made of the right materials, and occurring at the right time in the development of planet Earth. If any one of these factors were off by just a few percent, the Earth would be barren today. Unless that impact had occurred, Earth's atmosphere would be much heavier than it is, even heavier than that of our neighboring planet, Venus. Venus's thick carbon dioxide-filled atmosphere would mean instant death for all possible life. The extra mass Earth gained from the collision, along with its atmospheric revision, meant that water could exist on Earth in all three states: ice, liquid, and vapor, and in huge supply, a supply absolutely essential for an efficient, consistent water cycle. And that water cycle is essential for life, both for its existence and survivability. Well, that was part one of 6 parts we'll be showing you from our Journey Toward Creation documentary. And what we're really doing here is taking you on a journey from planet Earth to the very edge of the universe. And as you saw there in the introduction, the farther away we look, the farther back in time we're seeing. And the farther back in time we're seeing, the closer we are to the creation event and the one that's responsible for that creation event. What you'll be seeing in these next 6 episodes is how the evidence for the Creator God of the Bible as the author of the universe will get stronger and stronger the greater back in time we see. And so I often joke with my wife that I'm completely ignorant of the present as an astronomer, but I can tell you about the past.
A lot about the past. That's quite a remarkable fact that I think, while it's repeated often, and you certainly call attention to this, I don't think people realize that. It's hard to conceive of that you're looking further and further and further back into time when you look, as you point out, further out into space.
And it's not an inference or some kind of indirect evidence like you would get in geology, where you kind of infer events from the past by what you see on the ground. Astronomers truly are direct witnesses to what happened in the past. And in that sense, when skeptics say, well, no one was there to see the creation, so how can you make these such strong statements about it? That's really inaccurate. Astronomers are directly witnessing the past, and in that context, are direct witnesses to the creation event itself. In fact, you'll see that we'll wind up taking you to that moment back in cosmic time when light first separated from darkness, and we'll even show you what was happening before light separated from darkness. In that sense, we really are able to take you right back to the creation event itself. But this first episode, we got as far away as the moon, so we're just on the very beginning
of this journey. There was some introductory remarks, of course, made about the creation event, and one of the words that was used, a very common word, speaking, of course, about the Big Bang, was it referred to it as an explosion. And a lot of people have, it's natural, of course, to use that word because it sort of has some of those characteristics of an explosion. But what it does not have that's typical of an explosion is this chaotic kind of event that's take place. In fact, the Big Bang and this supposed explosion at the beginning was an exquisitely fine-tuned event. Maybe you'd like to comment a little further.
That's a good comment you're making, Dave, is that the creation of the universe, the expansion of the universe from its inception, is the least chaotic thing we observe anywhere in the universe.
Yes.
I mean, this is where we see the greatest evidence for design. This will come up in the future episodes, but it's probably good to let people know at the outset this isn't chaos, this isn't random evolution. This is extremely well-designed expansion from the creation event, like the Bible talks about. I mean, one thing that you won't see in this documentary is what we've written about in our other writings, how the Bible said it first. The Bible was the first document to talk about the universe having a beginning of matter, energy, space, and time, and a universe that continuously expands from that beginning, and expands in a way that's highly controlled by the Creator. Job says that God alone expands the universe. So he's the one that's intimately involved, making sure it expands at exactly the right rate. And to give people a feel for that, we're talking about this, quote, explosion from this point of beginning. The expansion from that explosion must be fine-tuned to within 1 part in 10 to the 56. Or there's never going to be the possibility for life existing in the universe. So this is where a scientist see the greatest evidence for supernatural design is in this so-called Big Bang explosion of the universe. This highly controlled.
Very, very finely. In a way, an atomic weapon has to be extremely fine-tuned as well for it to work. An atomic bomb has to be exquisitely designed in order for it to function. In some ways, you could draw an analogy here. A hydrogen bomb, for instance, has to have a combination of a very carefully controlled and tuned material there in the presence of an atomic bomb. The nuclear fission process, initiating the fusion process, and all of that has to be very carefully designed for it to work. And in some sense, the same thing has to be true of this Big Bang event.
Well, I think you're talking to the trigger mechanism for, say, an atomic bomb or a hydrogen bomb, and certainly that's implied in the beginning of the universe, that there is supernatural, exquisite design there.
Yes.
But it continues from the creation event forward. Unlike a hydrogen bomb where all the design is in the ignition of the bomb.
Ignition, and then boom.
What we see in the universe is that there is this extreme fine-tuning on the part of the Creator from the beginning point onward. Well, we talked a little bit about the moon, Dave, and what you see in the documentary is just how this collision, and I like the way our documentary put it, the primordial Earth did not look at all like Earth. It was
probably more like Venus, maybe.
More like Venus, just this very dense atmospheric cloud layer, and how the Earth received a collision from a planet, actually the size of Mars. That mass has been pinned down pretty well by astronomers' calculations. And we talked a lot in the video about how it had to have that this collision gave the Earth, transformed the Earth from a body whose atmosphere would make it impossible for life to exist to one where you could have this thin atmosphere and extra mass that would allow the water conditions that would make possible not just primitive life, but advanced life over the history of the Earth. But one thing we didn't talk about is how this collision brought about an important transfer of mass, in the sense that one of the things that they found when they went to the moon and recovered some rocks, the lunar rocks are a lighter composition than Earth rocks. And they date a little bit younger than Earth rocks, which tells us that the moon formed a little bit later than the Earth did. But this collision event would have the impact that the heavy material in the collider would be absorbed into the Earth. The light material in the collider and the Earth would be thrown into outer space. That little
the
video clip we showed you.
Yes.
And you notice the different colors.
Yes.
The different colors in that video
were the different density of material.
Different density. So what happened is the Earth became a denser body than it would have without the collision.
Okay.
And then the moon became a lighter density body.
And of course smaller in size, physical size.
Right. But it gives us a planet Earth that has a higher density than it otherwise would without the collision.
Okay.
And that higher density is critical for life.
Certainly for maintaining an atmosphere in the way that it does right now.
Well, the extra mass helps it to retain the atmosphere. It's critical for life.
The lighter gases in the atmosphere.
But the composition of the Earth that it gained from that collision is also critical, because the Earth became more iron-rich, became more rich in the radiometric elements, uranium and thorium in particular. And as those heavy metals, and particularly the radioactive ones that are so helpful for life. Now, people might say, well, how can life benefit from radioactive elements? Well, it's those radioactive elements that provide the heat source that drive the plate tectonics.
Which is important for...
Well, for example, there would be no continents on planet Earth. The Bible tells us that when God created the Earth, He created the Earth as a water world. The ocean encompassed the whole surface of the Earth. And geophysicists now know that that's the correct primordial condition for planet Earth. And it was this uranium and thorium that the Earth gained from this collision that was able to drive plate tectonics at an efficient enough level that it would produce continents. So what you see in Genesis 1, the third creation day, let there be these great land masses. We need to thank God for making sure
providing that collision.
We had the collision at the right time, the right place, the right mass of the collider, so it brought about this transfer of heavy elements to the Earth.
And if I recall, the way in which the Mars-like planet encountered the Earth is critically important as well.
It is.
It's a glancing, not too glancing, not too direct,
glancing, but not head-on
either.
Not head-on either. Where it hit relative to head-on is critical for this transfer of the heavy element material to the Earth, so we can have the just right elements.
So it's a very finely tuned process.
Incredibly fine-tuned. I mean, again, for advanced life, you need a suite of these heavy elements, and you need this long-lasting plate tectonics. You need a strong magnetic field in the core of the Earth, And all that's here thanks to this collision. It also helps explain why Earth is so unique amongst the solar system bodies. We were the only one that experienced this collision. And it really makes Earth kind of the heavyweight champion of the universe in terms of how rich it is.
You don't have to go very far out from the locality of the Earth to see the design already present in the solar system and in the Earth's
well, in that
history
context,
here.
the more we learn about the moon, the more evidence we gain that there's a supernatural creator that fine-tuned both the Earth and the moon. For the benefit of life.
And of course, the size of the moon and its distance is critical for life here on the Earth in terms of tides. And
tides, right. It stabilizes the tilt of the rotation axis for Earth. So yeah, there's dozens of reasons why we can look up the moon and thank God for creating that moon so we could have a nice place on the planet in which we can live. In fact, some astronomer even wrote a book, What If the Moon Didn't Exist?
There was I remember you calling attention to that book before.
Right.
Many, many reasons why the moon didn't exist. We would have a difficult time here on the Earth.
That's correct.
Yeah.
So, well, next time we'll look at episode 2 and take you out from the moon to a little further away. And you'll have an opportunity to see the accumulating evidence for the Creator God in the Bible as we proceed deeper and deeper into space and deeper back into time to that moment when He brought the universe into existence. So join us next time as we look at part 2 of this journey toward creation. Welcome to Reasons to Believe, the television program where we show you new reasons to believe in Christ as Creator, Lord, and Savior. Keeping you abreast of the latest scientific advances that are giving us new evidences, new proofs for the Christian faith, the accuracy and reliability of the words of the Bible. And what we're doing in this series is taking you through our journey toward creation video production. It's completely redone, it's updated, it's expanded, giving you much stronger evidences for the God of the Bible and what we were able to do in our original journey toward creation, which we showed 5 years ago in the Trinity Broadcasting Network. It's 70 minutes now rather than 58, and we are what we did in episode 1 is we took you from the planet Earth out to the moon, and where we're actually going to take you is all the way back to the creation event itself. And the theme is that the farther back in time you see, the more evidence you have for the Creator. But I also wanted to thank all of you that have taken the time to write into our show with your comments. I mean, we really do take those seriously as we plan new episodes to show on this program. And Dave, you got a letter from...
Yes, we get a lot of mail. It's hard to choose, but this is from Dwayne in California. He says, I have been watching your program at 4:30 a.m. Tuesdays, and it is worth waking up at such an hour. So he's willing to wake up at that hour. He says, your program should be on prime time, 7 days a week, not only on TBN, but on PBS and every other network in the world.
He's enthusiastic.
So there's a real endorsement for us. He says, I thank God for your program, which can give Christians logical explanations, which can be effectively used in relating to unbelievers. And so he says, thank you and God bless you.
Well, this is something that we've paid some attention to in the second edition of Journey Toward Creation, trying to make it much more attractive to non-Christian readers. And so we've packaged it in such a way that it really focuses on those things that they've been hearing about in the news and giving explanations that they won't hear, for example, on PBS. And it's also more up to date. And this is episode 2. Episode 1, by the way, if you missed episode 1, we do archive these shows on our reasons.org website, so you can get caught up. And the second episode will take us from the moon out to the inner planets, all the way out to Mars and Jupiter. Right. And we're going to focus on some of the things we learned there about the origin of life. So here's episode 2. Besides the Moon and an occasional asteroid, Earth's nearest neighbors are the planets Mercury and Venus on the inside, between the Sun and the Earth, and Mars on the outside. Our closest neighbor, Venus, like Mercury, is so close to the Sun that the Sun's gravity has worked like a set of brakes on its rotation period. Venus takes 244 Earth days to spin around just once. Our planet rotates about 4 times more slowly today than when life first appeared. Scientists have determined that a more radical change in Earth's rotation rate would have been catastrophic for life. Mercury, like the Moon, has only a slight atmosphere. Therefore, since virtually no erosion has occurred, Mercury's oldest geologic features remain, the scars of ancient impacts by asteroids and comets. Mercury's meteor-scarred landscape documents for us the early history of the inner planets, a time of intense asteroidal and cometary bombardment. This heavy assault not only took place on Mercury, but also on Venus, Mars, and the Moon. Likewise, the primordial Earth was not spared from this intense bombardment, even more so because of Earth's greater mass. This heavy bombardment resulted in searingly hot conditions, hot enough to vaporize the Earth's oceans and melt the Earth's crust. Obviously, no possibility for life existed at that time. For decades, scientists theorized that life on Earth arose from a vast collection of non-living molecules called the prebiotic soup, a process that required billions of years. But now research has shown that life arose quickly, in less than a few million years after the late heavy bombardment. In addition, there is no evidence for a prebiotic soup. If there was a prebiotic soup, we would expect to find the remains of it in ancient carbonaceous material, such as kerogen and graphite. As it turns out, all carbonaceous material on and in the Earth comes from postbiotic material, the decay of established life. Given so little time and the absence of a prebiotic soup, some scientists now look to the heavens for answers to the origin of life problem. They look up, not for a supernatural cause, but to search for other sources which could have deposited the seeds of life on the early Earth. Could life have arisen on one of our planetary neighbors and then have been transported to Earth? Many scientists are now looking to other planets to find support for this idea. But even if we were to find life on a nearby planet, where did that life come from? How can we be sure of any life we find on a nearby planet is not really a cross-contamination from the abundance of life on Earth? The Earth is brimming over with life. It's only a matter of time before we find the remains of these Earth organisms on Mars. And many scientists will claim this is undeniable proof that life arose by natural processes there. But a simple test exists which would prove these organisms came from Earth. All DNA has a consistent complex signature or order to its structure. This signature is passed down from each living organism before it. If the DNA signatures found in the remains of life on Mars match that of the DNA found in life forms on Earth, then the only logical conclusion is that the stuff on Mars must have somehow come from Earth. Just as asteroids and comets colliding with Mars can send Martian rocks to Earth, so too collision events on Earth send Earth rocks to Mars and the rest of the solar system. While Mars is the best candidate beyond Earth for finding the remains of Earth life, it offers a far from hospitable environment. Mars is so dry, its atmosphere so thin, and its gravity so weak that a drop of water evaporates in less than 1 second on the Martian surface. Radiation, violent storms, instabilities of axis and orbit, and freezing temperatures lower than the Antarctic winter mean life cannot survive there, at least not for long. Billions of years ago, Mars had a warmer and wetter climate, which led scientists to speculate it could have spawned life. However, the chemical environment of early Mars was even harsher than Earth's, making a naturalistic scenario for the origin of life impossible. The next stop on our flight is the giant planet Jupiter, 10 times farther away from us than Mars. At a distance of 400 million miles from Earth, we have traveled less than a millionth of an inch on our journey from the Space Needle to the Empire State Building. Jupiter is 40 light minutes away from Earth. That means it takes light from Jupiter 40 minutes to reach the Earth. Jupiter is such a colossus that it outweighs by 2.5 times all the other planets in our solar system combined. The giant red spot we see as we look at the top of Jupiter's dense atmospheric layers shows a 2,000 mile-per-hour hurricane raging for centuries. To give some perspective, that spot is 4 Earth diameters across. Of Jupiter's several dozen moons, Io, Europa, and Ganymede are the 3 most closely studied. Each of them is larger than our moon and less tranquil. Io sometimes suffers violent volcanic eruptions. Some astronomers believe Europa may have subterranean liquid water, and that this water spawned life. Given the importance of water, it's no surprise that scientists have named Europa as a candidate for life. But recent studies of the craters on Europa's surface have established that its ice sheet is at least 12 miles thick. Such thick ice prevents any oxidants from reaching whatever subterranean ocean may exist. Without oxidants, no metabolism. Without metabolism, no life is possible in Europa. Moreover, as we shall continue to see, water is but one of more than 200 physical characteristics that must be met for life to survive, let alone what it takes to generate life. Researchers in the 1990s sought to probe Jupiter's many mysteries, such as the degree to which light penetrates those thick clouds, and whether the planet has a rocky core or just super dense frozen gases. In the course of their investigation, they discovered evidence of Jupiter's importance to Earth life. Jupiter is positioned and dimensioned to shield Earth from collisions. The planet's nearness and mass typically deflect comets and asteroids that are moving on a collision course with Earth. Occasionally, Jupiter itself takes the hit, as in this 1994 encounter with comet shoemaker Levy.
Though each fragment of Shoemaker Levy was smaller than Manhattan Island, 21 of them raised fireballs more than 10,000 miles high and made Earth-sized bruises in Jupiter's atmosphere. Any planet capable of sustaining life needs a just right-sized Jupiter standing guard to shield it from life-ending asteroid and comet impacts. Jupiter's size and position are important to Earth life for yet another reason. If Jupiter were any larger than it is, or any closer to Earth, its gravity would wreak deadly havoc on Earth's orbit. Jupiter is a just right size protector in a just right location.
Well, that was part 2 of 6 parts we'll be showing you from our Journey Toward Creation television documentary, where we take you on a journey from the surface of the Earth out to the very limits of the cosmos. The farther away we look, the farther back in time we're seeing, and the closer we're getting to the creation event itself. And Dave, when we had that first episode, we were looking at the journey from the Earth to the Moon. And it's like the more we learn about the Moon, the more evidence we're seeing that the Creator is responsible for the Earth and Moon.
Design that's present there, and the fine-tuning.
So that Earth can have life on it. Well, now we're moving into the inner part of the solar system, and likewise, the more we learn about Mars and Venus and Mercury and Jupiter, the more we're discovering just how fine-tuned our solar system is, and planet Earth in particular, that life can be supported on this planet. But I think what I really wanted to put into this documentary is how our study of the inner solar system is really helping us to come to grips with the origin of life enigma. How did life arise here on Earth? And we were just showing you that scientists cannot figure out how life arose on planet Earth. And it's more than just not figuring out. They're coming to the conclusion there is no naturalistic pathway for the origin of life on planet Earth.
Well, especially in the short time frame that we find between the sort of beginning of the Earth and an environment where life could even possibly exist, and the time when life, in fact, is found to have existed.
Yeah, we talked about the postbiotics. Well, we can date how far back in time those postbiotics go, the decay products of once living organisms. And the answer is we know that it's been abundant on planet Earth as far back as 3.8 billion years.
How far beyond the time when this bombardment took place?
Well, the late heavy bombardment peaked at 3.85 billion years ago.
So we're talking 500 million years then after.
Well, it takes about 50 million years for this late heavy bombardment to subside. So you take 3.85.
Oh, excuse me, 50 million years, not 500.
And it's actually briefer than that, because the peak is at 3.85. It takes time for that late heavy bombardment to subside. By the time it subsides to where life is possible, you immediately see life on the Earth. It's like you can do the math. If it subsides at 3.8 billion, and we have the evidence for life at 3.8 billion, that gives you a time window of 3.8 minus 3.8 for the origin of life. That's a virtual geologic instant.
Instant in geological terms.
That and the fact that there's no soup. I think late people can appreciate that. If you have no time and no soup, then there is no naturalistic...
Now, what is it, when we say there's no soup, kind of what do we mean by that?
Well, you would get a different carbon-12 to carbon-13 ratio signature for molecules that we would classify as prebiotics.
Right.
These would be fairly complex carbon-based molecules that have the potential for coming together to form life. But that would have a different signature than those same molecules that are a result of organisms that decay.
Right.
And so chemists can determine whether or not these molecules are prebiotic in nature or postbiotic.
These are the leftover materials that are sitting in the bottom of oceans or...
From life forms that died, right. And the answer is we see postbiotics, we see no prebiotics. And physicists now understand why we don't see prebiotics. If there's even the tiniest amount of oxygen in the early Earth's environment, that will slam the door shut on the prebiotic pathways that could lead to life. So if there's oxygen, you're not going to get prebiotic chemistry. On the other hand, if there is no oxygen in the Earth, ultraviolet radiation from the sun will stream in,
to life.
and that ultraviolet radiation will put a stop to prebiotic chemistry. And geochemists refer to this as the oxygen ultraviolet paradox.
You're caught between a rock and a hard place here.
If you got oxygen, it's not going to happen.
Right.
If you
In
don't have
naturalistic
oxygen,
ways.
if you don't have oxygen, it'll also not happen.
Right.
Therefore, there's no naturalistic explanation for the origin of life on planet Earth. Now, those who resist concluding that there's a supernatural creator that intervened in a miraculous way to make life on planet Earth say, well, if we can't figure out how it happened on the Earth, we know there's no naturalistic possibility for it happening on Earth, how about if we go to Mars?
Bring it in from someplace
Or how
out.
do we go to Europa or Titan? So that they look elsewhere in the solar system with the idea that maybe it could happen there and get transported through meteors to the Earth.
So their hope would be that, for instance, the early environment on Mars was somehow more amenable to the idea of life beginning than what we find here on the Earth. But of course, Mars was subjected to the same kind of bombardments and physical conditions that we on Earth were.
That's where scientists speculate that the early Mars may have been wetter, because that late heavy bombardment would have brought comets, and comets are 75% water.
Yeah.
So I would give a water input to Mars, but conditions on Mars are such that for it to be warm enough for the water to be in a liquid state, you would need a lot more carbon dioxide in Martian atmosphere at that time, and that carbon dioxide will immediately react with the water to make carbonic acid, which reacts to make the carbonates. The bottom line is, if Mars was ever warm enough for liquid water, that liquid water would remain there for an incredibly short period of time. It would immediately chemically react with the carbon dioxide and produce these carbonates. Didn't happen on Earth because Earth never had that much carbon dioxide in the atmosphere. Mars might not have either, in which case it would have never had liquid water. However, Mars would be subject to the same ultraviolet oxygen paradox that Earth was. And therefore, however difficult it is on planet Earth, chemically it's even more difficult to make it happen on Mars. You got the same very short time window, and we know there's no possibility of a soup. And that's why there's speculation about Europa, because there you got the speculation for underground water. But there you get a different paradox. You need oxidants for even the most primitive life forms to be able to generate their metabolic reactions. And the ice is thick enough to protect that life on Europa from ultraviolet radiation. It will be too thick to permit the oxidants to get through. Bottom line is, Dave, we now know that the solar system is a non-candidate wherever you go, whether it be Titan or Europa or Mars or any other solar system body. In none of these locations is there any possibility of a naturalistic explanation for the origin of life.
One of the things that I just was hoping that we could make sure people get a clear picture of is the Earth, when it was first formed, did have a water surface, is that right? And a very thick cloud layer. And then sometime during that early history was when this bombardment took place. And evaporated. Now, prior to that bombardment, there were no continents or mountains or things of that nature. Is that our understanding? It was pretty much covered by water?
Well, very recently, geochemists have been able to recover zircons that date previous to the late heavy bombardment. Zircons are very tough crystals, and a few of them are able to survive that late heavy bombardment. So we get a picture of what it was like before the late heavy bombardment. And there were episodes before the late heavy bombardment where you would have liquid water. Now, how much, we don't know.
So it wasn't necessarily covering the whole surface.
Well, we also find that there must have been some rocks that were exposed to the atmosphere. So, but
in that early phase.
right.
Then there was the bombardment, where there was a kind of a recreation of the surface of the earth, in a sense, that
with the crust
any water that
molding.
was there was evaporated, and the crust was
And following the late
liquefied.
heavy bombardment, water would liquefy again.
yes.
The steam would liquefy, and this would have covered the whole
So
surface with water.
that picture then of the early earth that we have from the Bible would be after this late bombardment,
Right.
when the earth was really truly covered by an ocean.
That's correct.
Okay,
Right.
that's a picture that sometimes it's a little, when you hear these sequences that are given in the programs, you're not sure exactly where we're supposed to think in terms of the description given in the Bible, or when life was. So life, there's no evidence of life having been present in that earth prior to the bombardment, this late heavy
That's
bombardment.
correct.
The evidence that we have for life is after that period of time.
And if you were to speculate that there was life in that early era, I mean,
It would have been destroyed by
it would
that
have been
bomb.
destroyed, and I'm very skeptical of those kinds of speculations, because for the first 500 million years of its history, the sun was pouring out intense X-ray radiation. And it's hard to conceive of any life on
Life
planet Earth
surviving.
previous to the late heavy bombardment being able to withstand this intense X-ray radiation. The sun wasn't as stable in terms of its luminosity
in that early phase.
in that early phase.
Okay.
So 3.8 billion years ago is really the first opportunity for life on planet Earth.
and are being able to actually detect it,
Right.
or the chemicals that remain from it.
And of course, these are just a few of many, many requirements that are necessary for the origin of life and the survival of life on planet Earth. I hear NASA scientists say follow the water, but there's a lot more
A lot
than water.
more that's required than just water.
That's correct. So,
I guess we're coming to the end here of this.
yeah, we'll be showing our audience episodes 3, 4, 5, and 6 in the next weeks in that consecutive order. And we again would encourage your comments on what do you think about this documentary, and ways that we can help you gain more evidences for the Creator God of the Bible in the future productions that we'll do. So thank you. Welcome to Reasons to Believe, the television program where we show you new reasons to believe in Christ as Creator, Lord, and Savior. We're a group of research scientists at Reasons to Believe that are developing evidences from the frontiers of scientific research that the God of the Bible indeed is the creator of the universe, the shaper of all life, and the words of the Bible are trustworthy and reliable in every respect. And what we're doing in these episodes is actually taking you through our brand new production, Journey Toward Creation. It's a television documentary that we developed. We showed it 5 years ago, but we've been able to completely revamp it. It's updated, it's expanded, vastly improved with a lot of new technology that wasn't available to us 5 years ago in terms of animation and taking advantage of the latest video and photo footage that we can get from observatories and satellites from around the world. So we're going to be showing you episode 3 today. And this whole production really is a result of communications we got from you, the viewers. And we appreciate the many letters and comments we get from you, suggestions for things that we can do in the future, ways we can improve this program. And Dave, you got another letter here from one of our constituents.
I've got another letter, and just to show you that it's not just in the U.S., this is coming from Scotland, the United Kingdom. And this is Laura writing, and she's, among other things, says, I have been delighted to discover Reasons to Believe, and am thrilled that TBN is broadcasting it so that many souls around the world can discover that science and the Bible are compatible, really are compatible after all. Many thanks for all of your good work in this area. Yours in Christ. So that was a very encouraging letter from someone on the other side of the world.
Well, we actually do get a lot of mail from countries overseas. In fact, I was just on the airplane the other day and ran into a gentleman from Nairobi in Kenya.
Oh, okay.
And he watches our show on a regular basis over there in Nairobi. So, yeah, in that sense, this is having a worldwide impact. And that's one reason why we've launched Reasons to Believe sister organizations in other countries, is to realize that this is a message not just for Americans.
Right. People from all over
Right.
appreciate it.
Well, what we want to show you in this program is another segment from our Journey Toward Creation television documentary. We've been taking you from the surface of the earth to the very edge of the universe. Episode 1, we took you from the earth to the moon, where we saw the more we learned about the moon, the more evidence we have that there is a creator that shaped the Earth-Moon system for the benefit of life. Then episode 2, we went from the moon out to the planet Jupiter, looking at the inner solar system. And once again, we see through the latest discoveries that the more we learn about our inner solar system, the more evidence we uncover for the supernatural nature, the origin of life on planet Earth, and for the development of life from that first life form to human beings. What we want to do now is take you to the outer solar system, and astronomers for the first time are finding planets outside our solar system. Over 100 have been found. So I want you to take a look at this third episode in our Journey Towards the Creation event.
Traveling another 40 light minutes out from Earth, we arrive at another giant planet, Saturn. Saturn has about a third of Jupiter's mass, and it still outweighs all the planets other than Jupiter by several times. 1,000 Earths would fit inside Saturn's volume. Titan is Saturn's largest moon, and has gained notoriety as another possible candidate for prebiotic chemistry. Titan is the only solar system body besides Earth with a significant atmosphere, one which contains high levels of nitrogen gas. Unfortunately, Titan has no ammonia and only trace amounts of water and other oxygen compounds. Without these critical ingredients, none of the building blocks of life molecules can be chemically assembled. The next two planets we encounter are also gas giants, Uranus and Neptune. Uranus is 15 times more massive than Earth. Like all planets this large, including Jupiter and Saturn, it's mostly gas. Uranus, like Saturn, is surrounded by concentric rings. But unlike any other planet in the solar system, its rotation axis points toward the Sun. Neptune, just slightly larger than Uranus, features a great dark spot, presumably a large, stable hurricane like Jupiter's Great Red Spot. Neptune's largest moon, Triton, orbits in the opposite direction to the planet's rotation, leading us to conclude that it was captured after Neptune's formation. Neptune is more than 4 light hours away from Earth. From Neptune's surface, the Sun would appear as just a bright point in the sky. Neptune is so frigid that ammonia and nitrogen would liquefy there and gasoline would freeze. These 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, travel in unique, almost circular orbits on a horizontal plane around the Sun. This stands in stark contrast to gas giants so far discovered outside our solar system, which either orbit too close to their stars or have elliptical and/or non-horizontal orbits. Even a slight deviation from their appointed paths would be catastrophic for life on Earth. Traveling out almost 6 light hours from Earth, we come to Pluto and its companion Charon. Pluto is the smallest planet in our solar system, smaller than our moon, made mostly of ice. Pluto's moon Charon is less than half Pluto's size. Beyond these frozen outposts lie other tiny bodies orbiting the Sun. Now we reach the last stop before departing our solar system, a vast area of asteroids and comets. The inner ring is called the Kuiper Belt. The density and positions of these asteroids act as a stabilizing force for the orbit of Neptune. Without a finely tuned gravitational tug from these space rocks, Neptune's orbit would be erratic, potentially catastrophic for our tiny planet. At the outer edge of our solar system, orbiting the Sun up to 2 light-years away, lies a vast area of over 100 billion comets known as the Oort cloud. Occasionally, some of these comets are disturbed just enough by the gas giant planets to be pulled out of their orbit and hurtled toward the inner solar system, including the Earth, replenishing our water supply and delivering other vital nutrients. On our trip across the United States, we have traveled just 0.04 of an inch from the base of the Space Needle toward the Empire State Building. As we leave our solar system, we travel more than 4 light-years to Alpha Centauri, the nearest star to our solar system. Only about half of the stars in the entire universe are classified as single or bachelor stars like our Sun. Alpha Centauri is not a bachelor star. It is one of the common multiple star systems. The gravitational tug-of-war in Alpha Centauri makes stable orbits for planets capable of supporting life impossible, so the majority of stars are ruled out as possible life support sites. As we continue on our way, we discover that stars come in different sizes, colors, and ages. The bigger the star, the hotter, faster, and more erratically it burns up its fuel. Stars more massive than the Sun burn their fuel too quickly and erratically to support life in their vicinity. Stars less massive than the Sun are cooler, so planets orbiting close enough to be warm enough for life would have their rotation greatly slowed by the star's gravitational tug. Slow rotation means long days and nights and life-destructive temperature extremes from day to night. Traveling 250 light-years out past Alpha Centauri, we encounter over 100,000 stars. Of these stars, only 100 of them so far have been found to have planets orbiting them. Scientists now estimate that only 2% of the stars in our galaxy possess planets. Most of the planets discovered so far are gas giants, several times more massive than Jupiter. All of them either orbit their star closely or have non-circular, non-horizontal orbits. Either way, they would destabilize any small rocky planets like Earth that might be near them. One candidate for a planetary system which bears some resemblance to our own surrounds a star named 55 Cancri in the constellation Cancer. At a distance of 41 light-years from Earth, this star is about 5 billion years old, just about the same size and age as our own Sun. This planetary system contains 3 gas giants, similar to those found in our solar system. But the similarities end here. While one of the gas giants orbits 55 Cancri at roughly the same distance as Jupiter orbits the Sun, it is 4.5 times more massive than Jupiter. This extra mass would disturb the orbit of any Earth-sized planets that might exist there. As for the other two gas giants, both orbit 55 Cancri so closely as to guarantee a deadly tug-of-war with any possible life support planet. So far, none of the extrasolar planets cataloged by astronomers possesses even one of the more than 200 design characteristics necessary for life. Chances are we'll find thousands of planets outside our solar system, but the possibility that we'll find a whole suite of planets like those in our solar system uniquely positioned to sustain life on one planet is growing more remote every day. Further out from Alpha Centauri, but still within our Milky Way galaxy, we also encounter hundreds of gas and dust clouds called nebulae. Their strikingly beautiful colors are created as the nebulae are ionized. Radiation from nearby large stars supercharges the electrons and sends them flying away from their atoms and molecules. As electrons escape from hydrogen atoms, they produce a red glow. As they leave oxygen atoms, they produce a blue-green glow. Gaseous nebulae may be described as stellar maternity wards. Our galaxy, called the Milky Way, is still giving birth to new stars. Our own sun is considered a late-born star, and as you'll see, life depends on that critical timing. Stars form within nebulae much the same way raindrops form within Earth's clouds. Gravity is a key factor. Gas and dust particles begin to pull together under gravity's influence. But as they do, more molecules collide, producing heat. As the particles continue coalescing, more and more heat results, especially at the core of that condensation. Eventually, the core becomes hot enough to ignite nuclear burning. At this ignition point, a new star is born. Since our sun also went through this type of birth process, most scientists classified it as an ordinary star. But several recent discoveries have caused astronomers to reconsider this assumption. Evidently, our sun is very rare indeed. Most stars are either too small or too big, too young or too old, contain too many metals or not enough metals. Our sun's radiation and its precise location in our galaxy are all critical factors for life. Well, that was part 3 of our Journey Toward Creation documentary, taking you on a journey from the surface of the Earth to the very edge of the universe, going back in time as we look farther and farther away. And we'll actually get you right back to the creation event itself. I think what you're seeing here is something we're trying to portray throughout this video, namely that the farther away we go, the greater the accumulation of evidence for a supernatural creator being responsible for this vast cosmos and life on the planet Earth in particular. And in episode 1, we got you out to the moon. Episode 2, we took you to Jupiter. Now we're getting you through the outer solar system to the nearby stars, and a dive into this fascinating new subject of extrasolar planets.
Right. By the way, at the rate we're going, it's going to take a long time to get to the beginning of the universe. Well, we're going to have to speed up our...
We will be speeding up our time machine, but the remarkable thing is we really do have available to us a time machine that lets us look far away, hence back in time, and see directly what the Creator did.
Yeah, this question of extrasolar planets is a very interesting one. Those of you who were able to come to our recent Reasons to Believe conference heard some discussion of this. I was able to give a short talk just discussing the problems that one encounters with looking for life outside of our present planet, let alone our solar system. And one of the things that's mentioned in the video here is the idea that life may have been brought here outside of our solar system, either on a perhaps a spacecraft that an alien has sent here, or on some kind of a meteorite. But when you consider how far away even the closest star is, I think the video has mentioned that the closest star is about 4 light years away.
Well, I've got a little model for that, Dave.
Okay, maybe we can give people a picture here of...
I mean, if these were... Well, let's model stars down to the size of oranges.
Okay.
Typical stars are about 1 million miles in diameter. We'll be modeling down to the size of oranges. Another way to get a picture of the vastness of space is to ask the question,
how far away would
if this was the
oranges?
sun, how far away would be the next nearest star on this scale?
On the same scale.
And the surprising answer is the next orange would be in Siberia or Peru.
Quite a distance away.
When we talk about outer space, it really is virtually empty of matter. Stars are far apart.
Well, and then the other issue is, of course, if something were to travel from that star to here, how fast could it go? And you've discussed that issue in your book on UFOs, and it seems like the evidence is that if we were to travel much faster than about 1% the speed of light, that any spacecraft or any life or anything would be destroyed by the intervening material
Well,
that
there's
it would
2
hit.
points here, Dave. The probability that our planet Earth would receive some kind of meteorite from another star or planetary system, Jay Melosh a few months ago calculated we would get one such rock every 10 to the 16 years. Now that's 1 million times more time than the entire age of the universe. So in that sense, we can safely conclude we've not gotten any of these.
It can't be some meteorite that was shot off by an explosion or something on that star.
There's no chance another meteorite hit a planet
by random.
Right, and then sent a rock to planet Earth. That's not how life could have got here. You're raising the other issue, well, maybe if there's intelligent life out there on a distant planet, who knows how that got there? We're going to have the same problems we would be explaining intelligent life here.
Life on the Earth. Yeah.
But even if God were to miraculously create life on another planet, intelligent life on another planet, they're not going to be able to send a spaceship here because of the vastness of space.
The distances that are involved.
And the fact that if they were to try to travel really fast, their craft would be destroyed by that high speed. So you're right, 1% the velocity of light is about as fast as you can go.
Which would mean at 4 light years away, that's 400 years.
Right.
So it would take 400 years for them, and of course we don't believe that there is any life in the closest star. We probably have to go a lot further away than that before we would find places where such life could possibly exist.
Well, for example, the attempts to search for signs of life in our near vicinity have been able to rule out definitively that there is no intelligent civilization as advanced as ours within a couple hundred light years. So now we're talking
20,000
years to make a trip minimum. And that's just to get a bacterium here, let alone something more advanced than that.
That's right.
But a thing I wanted to emphasize, Dave, is that we've now seen a little more than 100 planets outside of our solar system. And I remember when I was a graduate student in astronomy, there were people speculating that as soon as we discover planets outside our solar system, we're going to find that our solar system is not special. That all over our galaxy are other systems just like ours with the capacity of a planet like Earth that can support life. Well, so far our research is showing that prediction to be false. We are finding planets outside of our solar system and planetary systems. We're even finding stars that have multiple planets going around the star. But in every single case, at least so far, we're finding that the gas giants we see around those stars have orbits or masses that would not permit the existence of a planet like Earth with life upon it.
I'd like to just make a point, though. When you consider how many stars there are in this universe, we believe that there are 100 billion trillion stars, plus or minus an order of magnitude here.
Right.
Stars, and when you consider that many, and that about 2% of these stars may in fact have planets going around them.
That'd be for our galaxy. If you're talking the universe, the percentage is lower.
Perhaps
our
lower than that.
Our galaxy is planet rich.
But still, that's a lot of stars with a lot of planets.
Exactly.
It's very intuitive. It's very natural to think that you would expect to see planet systems that might be similar to what we have going around in our solar system, and you might find planets that could support life. So it's a very natural thing to think this, and it's not until you really begin to delve into the details. Isn't that always the case? The devil is in the details.
Exactly.
That when you look at the details, you find
the creator's in the details.
The creator, that's a better way of putting it. That you find that that there are many things that come to play, and that's of course our whole ministry here is calling attention to when you collect up all of these different probabilities, you find that in fact the probability of there being another planet like the Earth anywhere in the universe is, I think the numbers are something on the order of...
well, it's less than 1 chance in 10 to the 217.
217th, I remember that.
On our Reasons.org website, we actually have given you a history of the past 4 years of what new discoveries are doing to that probability, and we're seeing that it's getting more and more remote, typically by a factor of 1 billion times more remote with every 6 months of advancing scientific discovery. So the case for the Creator being responsible for planet Earth and life on it is getting exponentially stronger
as time goes
by.
I have another question. One of the points made in the program is that Jupiter plays an important role in protecting the planet Earth. How important are the other planets like Saturn and Neptune and Uranus in similar ways? Is that...
They are important. I mean, if you were to have Jupiter by itself do all the protecting that was necessary, then Jupiter would have to be massive enough or close enough to the Earth that would actually begin to tug on the orbit of the Earth and pull it in such a way that would disturb at least the possibility of advanced life on planet Earth. So it's important to distribute the protection among several gas giants. It's also important for another reason, Dave. With 4 of these gas giants, with their circular orbits, the way they're placed in position, it breaks up resonances throughout the solar system. And it's these resonances that would work to pull the Earth out of its life support zone. Bottom line is, you really need the entire solar system. All the planets have to have a very finely tuned design, mass and orbit and position relative to the Earth, or life will not be safe on planet Earth.
Now, they're not as finely tuned, of course, as, say, the creation event, 1 part in 10 to the 55, but they still are important for especially considering the longevity of life and life's history.
And the design of the star must be just right, as we saw at the tail end of that 3rd clip.
I guess we're here at the end.
Well, join us next time where we'll present you with episode 4, and we'll be taking you out into the outer reaches of our galaxy, and then we'll go beyond to the Creator himself. So join us, and we appreciate your comments and suggestions too. Welcome to Reasons to Believe, the television program where we explore the new reasons to believe in Christ as Creator, Lord, and Savior. At Reasons to Believe, we're a group of research scientists that are looking at the latest scientific advances and finding their new evidences for the God of the Bible and the accuracy of the words of the Bible. Literally on a daily basis, every day, there are several new discoveries that are giving us that additional evidence. And that's what this television program is all about. And but we do appreciate hearing from you. I mean, the letters we get from you really help us understand whether we're getting across to you, whether our technical level is too high or too low. And we really do appreciate hearing from you, suggestions, things you like, and the things you'd like to see improved. And Dave, you got a letter from our mailbox that...
Yes, another one of these encouraging letters. This is from Arthur in Ohio. And he mentions that he's been watching this television program for many years. And then he says, I believe your work to be very significant and of high integrity, being both truly scientifically accurate as well as scripturally sound. And I appreciate the attitude of love with which the truth is told. That's a very encouraging letter, and he, of course, greets us in the name of the Lord for what it is that we're offering here.
Well, thank you, Dave. And I've just read some letters from our constituents wanting to know why we focus so much on the new reasons. While there's many good Christian organizations that we feel are doing an excellent job commuting the older or more traditional reasons to believe in Christ, but it's been our experience that people outside the church typically don't respond well or aren't willing to listen to those evidences. So we're doing here at Reasons to Believe is to provide new reasons and use that as a bridge to the traditional reasons. Kind of like Paul when he was going into Athens, talking to the philosophers and wanting to hear about the latest ideas.
He was willing to meet them at their level,
right?
The things that were of interest to them.
So we want to do the same thing. So, and one of the ways we're doing that is we're showing you excerpts from a television documentary we've produced called Journey Toward Creation. And in this DVD and video, what we're doing is taking you on a simulated journey from the surface of planet Earth out to the very limits of the universe. And we call it Journey Toward Creation because the farther away astronomer looks, the deeper back in time he sees. Astronomy is that rare science where we can directly witness the past. And if you look far enough away, you become a witness to the creation event itself. Hence, Journey Toward Creation. And Dave, one of the things we've been noticing on our journey is that the farther away we look, the more evidence we see for God's supernatural hand.
All of these things that come together and are required to make the earth to be a place where we can actually live. It's remarkable.
Right.
The amount of tuning evidences and supporting ideas here.
Well, just to bring you all up to date, in episode 1 we took you from the Earth to the Moon, showed you the design in the Earth-Moon system that makes life possible on planet Earth. Episode 2 we got you out as far as Jupiter, and how the inner solar system is highly fine-tuned to make life possible on Earth. Episode 3, we looked at the more distant planets, the nearby stars, extrasolar planets. We can now see over 100 planets orbiting other stars. But the more we learn about the outer solar system, the more we learn about the nearby stars and the new planets that we're discovering, the more we're recognizing that our solar system is uniquely designed, miraculously designed, so life would be possible on this planet. What we're going to do in episode 4 is take you to the next level. We're going to take you right out through our Milky Way galaxy, then to the nearby galaxies. And we're going to see that we do not live in an ordinary galaxy. Ours is a highly fine-tuned galaxy for life. Let's take a look.
A few tens of thousands of light years beyond the center of our Milky Way, we arrive at the halo, where most of the oldest stars reside. This earlier generation of stars is important in the construction of life-essential elements. These ancient stars, in one sense, are the forebears to our planet and to our own existence. As stars exhaust their fuel and die, they bequeath to us their ashes, the heavy elements needed for the next generation of stars and for planet building. Our Earth could not even exist without 9 billion years worth of ashes from dead and dying stars. Stars about the size of our Sun, or smaller, lose their outer layers gradually. When the last of their nuclear fuel supply is exhausted, all that remains is a burnt-out core like a cinder after a fire. These cinders, called white dwarfs, take over 10 billion years to cool and play a critical role in our existence. For only on the surface of a special white dwarf binary star is the life-essential element fluorine manufactured. Without fluorine, certain proteins would be unable to form, and life in the universe would be impossible. Even more remarkable is the fact that even with as many as 1 trillion galaxies in the universe, our galaxy, the Milky Way, is likely one of only a few where sufficient fluorine production sites exist. When a star larger than our Sun runs out of fuel, the outer gas shells undergo a sudden collapse. They crash into the core with enough momentum to ignite one final eruption, an explosion so intense that when it happens in our own galaxy, it's bright enough to be seen during daylight hours. This final cataclysmic blast, a supernova, produces many elements essential for life: carbon, nitrogen, oxygen, phosphorus, potassium, sulfur, iron, copper, silver, and many others. It scatters them throughout the interstellar neighborhood to be absorbed later by star-producing gas and dust clouds. All of these various types of stars, in all of their various stages of life and death, play a vital role in our well-being. And far from being a waste, every minute of the past 14 billion years of star formation was necessary in order to enrich our planet with the elements that make life possible. Earth has been hung in precisely the right location to receive all the elements that are essential for life. Even though the stars in our galaxy are as numerous as the grains of sand on this beach, namely about 100 billion, many astronomers are now convinced that it's extremely unlikely that there could be another habitable planet anywhere among them. Even if the just right planetary system were to form from the just right elements of dead stars, there is another critical factor to consider. The life support planet must be positioned at the just right location within the galaxy. Near the center of our galaxy, conditions are too congested. With billions of stars in a relatively small volume, gravitational tug-of-wars make the survival of life-supportable planets impossible, and the radiation there is intense, far too intense for life. Toward the outer edges of our galaxy, the stellar population becomes too sparse for planet building. The heavy elements generated by supernovae and white dwarf binaries are too few and far between, not enough building material to make planets. At almost any distance from our galactic center, conditions within the spiral arms prevent planet formation. Amazingly, our particular solar system resides at the perfect location, in between spiral arms, neither too close to the center nor too close to the outer edge. Our just right location not only permits our existence, but it also allows us to see and explore our region of space. No wall of high-rises, no big dust clouds block our view. On our travel map across the ages, we reach the center of the Milky Way here at 25 feet from the Space Needle's base. Going past the center towards the halo, we add another few feet. When we are ready to exit our galaxy and move out into the vast reaches of space, we'll have come only a little more than 50 feet on our scale map. Our first stop beyond the Milky Way is the Andromeda Galaxy, slightly more than 2 million light-years from Earth. That means we're looking at Andromeda as it appeared a little more than 2 million years ago. Andromeda resembles the Milky Way in structure, but it's about twice as big. Together, our galaxy and Andromeda account for nearly 7/8 the total mass of the small galaxy cluster in which we reside, a cluster colorfully named the Local Group. The vast majority of galaxies reside in dense clusters, and these clusters must be ruled out as possible life sites. The gravitational tug-of-wars among these tightly packed galaxies render them unfit for life. Fortunately, our local group is not a dense cluster. Also, it is located in the extreme outskirts of another cluster, the Virgo cluster, safe from the gravitational wars. On our way to the Virgo cluster, we pass by several beautiful galaxies. In the South Polar Group, about 8 million light-years away, we meet with NGC 300 with its lengthy spiral arms. We can see them extending all the way out from the nucleus. Only 6% of the galaxies in the universe are spirals like our own, and only spiral galaxies can contain planets in stable orbits about their stars. This one design characteristic alone significantly restricts the number of potential sites for life. Just slightly farther along, we see NGC 253, a spiral seen edge-on. The nucleus is unusually small with no central bulge visible. M81, about 11 million light-years away, has a huge central bulge and rather thin, regular spiral arms. Even the size of a galaxy's bulge must be fine-tuned in order to sustain life. If the bulge is too large, then a planet like Earth will be blasted by deadly radiation. If the bulge is too small, then not enough planet-making gas and dust gets funneled to the zone in the galaxy where life support planets would need to reside. M81's neighbor, M82, is another spiral, but we see it edge-on. An enormous eruption of gas and dust is exploding out from M82's nucleus, perhaps ignited by a burst of star formation. Centaurus A, 15 million light-years distant, is highly irregular in that it has a thick dust lane perpendicular to the major axis of the starlight. More typical is the Sombrero Galaxy, where the axis of the dust and the axis of the starlight coincide. The location and quantity of dust in a galaxy is critical for determining whether or not any life-supportable planets can form. Just past 30 million light-years away, we find the Whirlpool Galaxy, actually an open spiral galaxy interacting with a smaller, irregular galaxy. The center of the Virgo cluster is 45 million light-years away. Here sits M87, an elliptical galaxy, one of the more common types of galaxies in the universe. Because of its shape and lack of spiral arms, it cannot give rise to life support planets. M87 is 10 times more massive than the Milky Way, and one of its distinguishing features is the black hole at its core. This hole weighs in at 2 million solar masses. 75 million light-years distant, we reach the Fornax cluster. It contains this beautiful spiral galaxy, NGC 1365. Some astronomers believe the bar may be a temporary feature caused by infalling gas. We see a burst of star formation along that bar. With galaxies packed so close together in clusters, collisions are inevitable. Here, two spiral galaxies are in the throes of a head-on crash. The next cluster we meet in our journey, the Hercules cluster, is over 400 million light-years away. Just from this cursory view of our galactic neighbors, we observe that a staggering number of factors must come together to sustain life. We need a just right planet with a just right sun, placed in the just right location of a just right spiral galaxy with a just right mass and the just right size bulge. That even one planet in a galaxy could contain all of these features seems nothing less than miraculous. By now, we have traveled 67 miles from the Space Needle on our way back to the Empire State Building. Well, that was episode 4 from our Journey Toward Creation video documentary, taking a journey from the surface of the Earth out to the very limits of the universe. And Dave, we covered a lot of territory in this segment.
A lot of ground. We're accelerating in speed now, moving out not just planetary distances or even star distances, but galaxy distances.
Yeah, we got all the way through our galaxy and all the way through the nearby galaxies. And I think the thing that just hit me, just looking at that again, is just recognizing that we understand that the galaxy and our cluster of galaxies, our solar system must be incredibly fine-tuned in order to provide a place where we human beings can exist. But the fact that the best design to provide us with a home is coincidentally the best design to provide us with a viewing platform to see the universe.
Very interesting concept.
I mean, only a supernatural creator could design things in such a way so that both designs perfectly match.
Came out together so we would have the opportunity to see the glory of the heavens.
Well, when you look at our spiral galaxy, it doesn't immediately hit you, but 99.99 and going on percent of the stars in our galaxy, you would not get a clear enough view for an astronomer there to even be able to figure out that we live in a galaxy. And the fact that we can not only see our galaxy, but see galaxies beyond, and not just the nearby galaxies, our Milky Way galaxy is in the just right location for life on planet Earth, but that just right location provides us with a unique window in which we can see the vastness of the cosmos.
Now, is there any sense in which the location of our galaxy, other than it being in a sparsely dense cluster of galaxies, is unique in the overall universe? Is there anything special about its position in that sense?
Well, astronomers are aware that you have to finely tune the number of dwarf galaxies and the type of dwarf galaxies relative to the spiral galaxy in which life exists. Because one of the things we notice about planet Earth, it's retained a maximal abundance of life on the planet over the past 3.8 billion years.
Right.
And for that to be possible, you need a certain infusion of gas and dust into our galaxy over the billions of years. It can't be too great, it can't be too small. You don't want these infusions of galaxies. I mean, you have this spiral galaxy, our Milky Way galaxy. It's gradually gobbling up these small dwarf galaxies. And if you can have those gobble up episodes distributed at the right time sequence, and the right types of...
They're not disturbing things too badly. And
because we pointed out, you need that infusion of gas and dust to sustain the star formation, to maintain that spiral structure.
To keep it looking like a spiral galaxy as opposed to an elliptical galaxy.
Right, and you know, with an elliptical galaxy, the stars now become jammed tightly together.
Right.
And orbits of planets around stars would be disturbed. But in order to sustain that spiral structure, you need stars, need small dwarf galaxies to be...
This would be an example, would be like the Magellanic Clouds that are just outside our galaxy.
Right.
They would be an example. Are they actually, I don't remember, are they moving towards our galaxy or moving away from us?
4 billion years from today,
They're going to come
the
collide.
large Magellanic Cloud will be absorbed by our galaxy. And that would probably be catastrophic to life if life were to last that long in our galaxy. Because it's one of the larger of the dwarf galaxies. But that's not what's been going on in our past. We've been absorbing the small ones. And this really explains, as we pointed out in the video, why it is that our solar system has the just right heavy elements for life. It's been getting an infusion of this gas and dust pulled into the center of our galaxy, thrown out to where our sun resides. And therefore our sun, as old as it is super enriched with these heavy elements that make advanced life possible on our planet. In one sense, we can look at the past 13.7 billion year history of the universe and recognize that it's pointing to a creator that's very aggressive. It's amazing that it can happen this quickly, that you can get all the elements you need for life
to come
together that fast. And unless our sun, for example, were to form right next to a type 1 supernova, which makes one suite of elements necessary for life, and a type 2 supernova, which makes a completely different set of metals that are necessary for life, both these supernovae, very different in kind, must explode at just the right location, at just the right time, relative to the new forming solar nebula, or you won't get a planet like Earth with the heavy elements that it needs for advanced life to be possible.
Now, these supernovae you're talking about are not to be confused with this Vela supernova that occurred here a few thousand years ago that is responsible for a lot of the radiation that we experience here on the Earth. You're talking about supernova prior to the formation of the sun itself.
Yeah, 4.5 billion years ago, there were two supernova events that took place to the new forming, that occurred relative to the new forming sun. And if they were too close to the solar nebula, they would have blown apart. If they were too far away from the solar nebula, there wouldn't have been enough of these heavy elements absorbed into the sun. But what's amazing to me, supernovae don't happen very often. It's like once every 100 years per galaxy.
Per galaxy, yes.
And the fact that you get these two exploding at the same time
in this neighborhood,
at the ideal location, at the ideal time for all this to take place.
Very remarkable.
That really does point to the handiwork of the Creator, making sure that everything is exquisitely controlled to bring about life.
One of the things that we didn't mention last time, I know we wanted to, was the stability of the sun itself. You want to make a comment about that?
Well, as stars are born, they're born highly unstable. Their luminosity can vary by factors of 10 or 20 over a period of a few days, which would be utterly catastrophic for life. But as a star matures, it becomes more and more stable. And therefore it reaches a point where its radiation won't kill life. That takes about 500 million years before a star would stop.
Settle down
enough that it's not blasting its environment with X-ray radiation, and there wouldn't be these wild fluctuations in its luminosity. And that would permit the Creator to create bacterial life on planet Earth, and for that bacterial life to survive, because bacteria are really hardy life forms. But the sun is still too unstable for advanced life, and really unstable for human life. And so as a star gets older and older, the flaring activity subsides.
It dies down.
And it reaches a minimum when the star is middle-aged. And at that point, it begins to increase again. Well, where do human beings show up in this whole sequence? Right smack in the middle. Surprise, at the ideal time. And this permits us not only to exist on our planet, but to exist with a maximum quality of life. We get to benefit from all the life forms that were created before us. They provide us with the biodeposits of bioresources that make our life possible. But then the entire universe we see is also here to provide us with a home and the best possible observing station. We wouldn't be seeing all this design evidence if we weren't at this very special location.
Special location, special time.
Special time and location where we can actually see the glory and power and love of the Creator revealed in our galaxy and the galaxies beyond. Well, in the next 2 episodes, we're going to take you all the way back to the creation event itself to show you the stunning images where we can actually witness that moment when light was first separated from darkness. So join us next time for episode 5. Welcome to Reasons to Believe, the television program where we look at the latest new evidences for Jesus Christ as Creator, Lord, and Savior. At Reasons to Believe, we're a group of research scientists that are looking at the frontiers of scientific research and demonstrating and developing therein new evidences, new proofs for the God of the Bible. Literally every day we are seeing new discoveries that are giving us new proofs for the Christian faith. And we really appreciate all the feedback we've been getting from you too in terms of how we can best structure this program to communicate these new evidences in a way that you can share with your friends. And Dave, I think you got a letter from the mailbag for us.
I've got another letter here, correspondence coming in. This is from Nita in Spokane. And she says, the first time I saw you, this is you, Hugh, it was on TBN talking about scientific facts. And I have a recollection of 2 paper doll figures.
Oh, I remember that.
My interest was stirred when you explained science and tied it into the things of God while not compromising either one. It was so satisfying to see science fit in with the Bible truths and to stretch my mind. And then, of course, she offers a greeting in the name of the Lord. So that was another encouraging thing and interesting, referring back to those times when you were doing the 2-dimensional figures, I guess.
Well, she'll have to watch, not this week, but next week. Next week we're going to get into the 10-dimensional universe, and now astronomers have discovered there's 10 dimensions to the universe, not just length, width, height, and time.
Yeah.
And of course that's got profound implications on the kind of God that created the universe. So that'll be next week.
Okay, so she'll have a chance to see maybe some of those 2-dimensional ideas expanded.
Right. And what Dave and I are talking about, for those of you that are catching our program new, is that we've been showing you week by week excerpts from our Journey Toward Creation video documentary. What we're doing is taking you on a journey from the surface of the earth to the very limits of the universe. And Dave, last time, our 4th episode, we got all the way out to our 67-mile journey. What we're doing is taking the history of the universe and trying to look at that entire history with a model where we take you from the Space Needle in Seattle to the Empire State Building in New York. And last week we took you out to a journey that got as far as the clusters of galaxies, these gigantic clusters of galaxies, and all the incredible fine-tuning we see and how a galaxy must be structured, its location relative to other galaxies, in order for life to be possible on planet Earth. The more we learn about the nearby galaxies, the more evidence we're seeing for its supernatural design to make life possible on our planet. But we ended the equivalent of 67 miles out from the Space Needle. We still have a vast journey to cover before we get to the creation event and the Creator himself. But in this 5th episode that we're going to show you shortly, you'll actually see us take you way past that 67 miles. We're actually going to get close to the creation event itself. So take a look, episode 5. Once we've reached this point, at 400 million light years from Earth, beyond the Hercules cluster, we come to a cosmological desert where the scenery virtually disappears. Not because there's nothing there, but because we cannot see clearly enough through our windows. Until recently, we had very few measurements and images of this region of the cosmos. Thanks to many new instruments, like the Keck telescopes, the Hubble Space Telescope, the COBE satellite, and others,
the curtains are beginning to draw back. Even so, information is still limited. Only a few dozen images are available. For our journey, this segment of space is shrouded in haze. But here and there, our telescopes pierce through to capture images of distant quasars and galaxies. Millions of galaxy clusters fill the universe, each containing thousands of galaxies, adding up to 10 billion trillion stars. That's 10 with 21 zeros after it. To try to get a handle on this colossal number, consider this. If 10 billion trillion dimes were stacked on top of each other, the line of dimes would make 125 trips to Alpha Centauri and back. As vast and innumerable as all these galaxies and stars may seem, and as tiny and insignificant as they make us feel, this enormity is essential to life's existence. In order for the universe to sustain even one life support planet, each one of these 10 billion trillion stars is a necessity. If the number of stars in the observable universe were any greater or any fewer, life would be impossible. If there were fewer stars in the observable cosmos, nuclear fusion would be so inefficient that the only elements to form would be hydrogen and helium. With more stars in the universe, all the elements would be heavier than iron. No carbon, no nitrogen, no oxygen. Only in a cosmos with a finely tuned mass of ours can the life-essential elements be produced. So as it turns out, the vast reaches of the cosmos are not a big waste of space, energy, matter, and time. When we travel to about 6 or 7 billion light years away from Earth, we are confronted with a remarkable discovery. In April 2000, scientists published the results of a landmark study in which they used a balloon-mounted telescope over the cold, stable atmosphere of Antarctica to test several characteristics of the universe. Known as the Boomerang Project, the cold, stable atmosphere of the South Pole enabled scientists to more precisely calculate the universe's rate of expansion. Apparently, for the first 8 billion years after the creation event, the expansion of the universe was slowing down, like shrapnel after an explosion. But the Boomerang experiments revealed that for the last 6 billion years, the expansion of the universe has been speeding up. Scientists discovered that there are two factors precisely governing the expansion of the cosmos throughout its history: mass density and space energy density. The mass density, which dominated the first half of the universe's existence, slows down cosmic expansion, while the space energy density, which dominates the more recent half of cosmic history, speeds it up. This delicate balance represents the greatest fine-tuning ever discovered. If the mass density were to vary by more than 1 part in 10 to the 60th, or the space energy density varied more than 1 part in 10 to the 120th, life would be impossible anywhere, anytime in the universe. As we move farther and farther away, farther and farther back in time, we begin to see some mysterious objects called quasars. Only since the mid-1960s have we built instruments capable of detecting them. Since that time, we have learned that when very large galaxies are young, intensely powerful plasma reactors form in their nuclei. These reactors burn with such intensity during this stage, called the quasar stage, a tiny core in the nucleus, a core no bigger than our solar system, outshines the rest of the galaxy by many orders of magnitude. Ordinary galaxies, far back in their formative stages, burn so dimly that only telescopes as powerful as the Hubble Space Telescope and the Keck can successfully image them. The galaxies shown here are so distant that the light picked up by our telescopes was emitted about 5 billion years ago. These galaxies are 10 billion light years away. They allow us to glimpse what the universe looked like at a third of its current age. Take a deep breath. Imagine how you might have felt at age 15 seeing a baby photo of yourself for the first time. This image from the Hubble Space Telescope carries us farther back in time than any optical telescope has ever gone. We're looking at the cosmos just a 500 million years after the creation event. No galaxies yet, only the building blocks of galaxies, pockets of condensed gas, and the process of forming huge clusters of stars. If we want to get close back to the moment of creation, we need to turn up the power in our time machine. We'll need a new mode of transportation to carry us the rest of the way back to the Empire State Building. Our new vehicles will be radio and far infrared telescopes. With these instruments, we can look back to the time before galaxies. If our eyes could see radio waves or infrared waves, we would be able to see distant galaxies more easily. But our eyes can only see electromagnetic emissions in the visible light wave spectrum. Waves in the radio part of this spectrum allow us to peer back in time even farther. This map of the cosmic background radiation, literally the radiation left over from the creation of the universe, carries our eyes as far back in time as any telescope can possibly take them. Here we are just 380,000 years away from the actual moment of creation. On our trip from the Space Needle to the Empire State Building, we have now arrived within 250 feet of our destination. We cannot look back any farther because 380,000 years after the creation event, light first separated from darkness. The view before that time would only offer a featureless glow. We can't see beyond this glow because previous to 380,000 years after the creation event, the universe was too hot for atoms to exist. Electrons could not orbit around nuclei. Because the universe was nothing but charged particles, an amorphous glow is all that appears. For an earlier look, we need to use entirely different vehicles, entirely different instruments, particle accelerators, supercomputers, and gravity wave detectors, not telescopes. With these machines, we can duplicate many of the physical conditions of the cosmos at its earliest moments. The study of the cosmos can be compared with the backward running of a fireworks video. As we measure and observe the cosmos closer and closer to the first moment of its existence, we are running the tape backward toward the moment of creation. As we draw closer still to the creation event, we observe the universe becoming hotter and hotter. Eventually, in this backward replay, the universe will be so hot that protons and neutrons can't stick together. All atomic nuclei fall apart.
At this point, we're just 3 minutes away from the creation event, less than 1/10 of a millionth of an inch from the Empire State Building, just a few molecules away from its base.
Let's push on. As we probe even earlier, we encounter a blinding flash, just 1 millisecond from the creation event. This flash is generated by the sudden annihilation of all antimatter in the universe. A delicate balance of 1,000,000,001 particles to every billion antiparticles guarantees the existence of matter in the later universe, and it also guarantees the possibility of life. Pushing back to just a few dozen microseconds from the creation event, protons, neutrons, antiprotons, antineutrons decompose into even more fundamental particles called quarks. At 1/10,000,000,000th of a second from the creation event, the universe is too hot and too dense even for quarks to exist. At 100 billionth of a trillionth of a second from creation, the universe is too compressed for light to be possible. The universe is now completely dark and smaller than a single atom.
Well, that was episode 5 from the 6 that we're showing you from our Journey Toward Creation documentary. And this is where we make the greatest transition.
Yeah.
I mean, we went from 67 miles outside of the Space Needle, and we get you to within a very tiny fraction of an inch of the Empire State Building.
We really accelerated.
So,
faster than the speed of light.
Actually, yes. But this is that portion, as we explained, of the universe where we're the most data thin, but thanks to discoveries made in the past few years, there's a lot more we can see in this part of the journey than we could previously. And again, this is where we're really seeing evidence for the Creator like nowhere else in science. And I want to emphasize for our viewers, Dave, that if it wasn't for the fact that our planet Earth was in the solar system it is, in a part of the galaxy that it is, and where the galaxy is relative to the Virgo supercluster and the rest of the universe, we wouldn't even have the tools to measure these fine-tuned characteristics. We wouldn't even be able to see the universe. But the fact that we're positioned at such an ideal location that we can witness all this is showing us the greatest design evidence that scientists have ever seen.
Now, if we were a little earlier in the history of the universe, we wouldn't be able to see as much because...
Well, as the universe gets older and older, more and more objects form.
Okay,
so if we were created any earlier, we would have less to look at, but it's also true if we were created any later, we have less to look at. And that's because this space energy density we talked about accelerates the expansion of the universe. And the future is going to cause the most distant objects in the universe to move away from us at greater than the velocity of light.
Right. They wink out, go beyond that horizon.
So this is the ideal moment in cosmic history when observers can see the most of what God has created. And we're at the ideal location. And we weren't at that location and at that unique cosmic time, we wouldn't be able to measure the universe and discern this incredible fine-tuning in the mass density of the universe and the space energy density of the universe. So I just stand amazed.
Yeah, it's amazing. Of course, we're talking about not, 10 or 20 years type difference. We're talking about a billion years difference. If we were a billion years sooner or a billion years later, then we would begin to notice these kinds of effects.
That's correct. But when you're talking about the window of time in which human beings can exist, where they can survive on the planet, it's far more narrower than that
because of other effects.
Because of other factors, right.
I'd like to make just one little comment. One of the things that's mentioned on the film is the tendency for those who are not believers in the Bible, that there's this enormous amount of galaxies and stars and so on out there that are kind of a waste. And as you've pointed out, they aren't a waste. They were very critical and necessary for there to be an environment where we can exist. In a sense, you could say that at this moment in time, for our living right now, they don't have to be there. They needed to be there in order for there to be at least one star like the sun in one galaxy like our galaxy with a planet like our planet. You could maybe in some sense remove it all right now, and we wouldn't know about it for 1 million years or whatever, because it takes that long for things to be affecting us.
Well, what we talked about in the documentary, Dave, is how the universe must have the just right mass density, or you're going to have a universe with nothing but hydrogen and helium in it.
Correct.
Or a universe with nothing but elements heavier than iron, and both ways you would lack the elements necessary for life.
Right.
But there's a second reason for that just right mass. If the universe, the rate at which the universe expands depends on how much mass you got in the universe. If the mass is greater, gravity will be stronger and will cause the expansion velocity to slow down more.
Right.
And so if the universe lacks the necessary mass, it'll expand too quickly.
Yes.
If it doesn't have the necessary mass, it'll expand too slowly. That's also true the space energy density terms.
Same reverse
You make
effect.
it too great or too small. And the fundamental problem here is that if the universe expands too quickly at different points in cosmic history, bits and pieces of matter will fly apart from one another at such high velocities that gravity will never have the opportunity to coalesce anything to make stars, planets, or galaxies.
Right.
And you need that for life.
But this was true in the history of the universe up till now. But if for some reason that we're all to disappear right now, there's a sense in which those galaxies out there right now are not directly affecting us.
Well, they are affecting us gravitationally.
Yeah, but it's...
if the Andromeda galaxy were to collide with us tomorrow, we'd be in trouble.
Yeah, in that sense. That would be a direct...
if there were no galaxies out there at all, we'd also be in trouble. This really helps stabilize what's going on.
But it would be 1 million years before we would be affected by it.
Oh, sure. Yeah.
It's just that some people kind of think that somehow all of that out there that we see is necessary right now for our life. And it's not so much that as it was necessary for the history of the universe to
play out the right way.
There's one other question that frequently comes up. We make these claims that these the space energy density or the mass density of the universe is so extremely fine-tuned. But we don't, in fact, have measurements of those constants to that kind of accuracy, to 1 part in 10 to the 50th. How do we know? In what indirect way do we know that they have to be therefore fine-tuned to that accuracy?
The best measurements we have on the mass density and the dark energy density are accurate to 1% precision.
1%, yeah.
And yet the fine-tuning is much greater than that.
We claim.
Right. Well, what astronomers do, just kind of like I was explaining, if you adjust the mass density or the space energy density ever so slightly, we discover as we work out the models of the universe that it won't produce a star like the sun.
Right.
Or if gravity is strong enough to bring stuff together, but you make it a little too strong, all the matter in the universe quickly finds itself relatively quickly inside black holes and neutron stars. And there again, you don't have the possibility for atoms or molecules or life chemistry.
It's kind of like the mid-course corrections. I'm, of course, familiar with, coming from the Jet Propulsion Laboratory, with the spacecraft navigation issues, where you want to send a spacecraft from the Earth to Jupiter, say. And there's some very fine, minor little adjustments that you make in the course of this spacecraft when it's, say, halfway to Jupiter that have an enormous effect on where that spacecraft ends up at. And you don't necessarily know precisely where the thing is at that midpoint, but you know some slight variation of it is going to have a big effect at the other end.
Right.
And I think it's sort of analogous to that.
Yeah, it all comes out in the models and the equations. You say, how much can I change it and still have a universe that's going to have the right objects for life, and you discover you change it. In fact, one physicist believes that the space energy density actually is fine-tuned to 1 part in 10 to the 240th. We know it must be fine-tuned to at least 1 part in 10 to the 120th, or there's no possibility for life. You know, and to put that into context, the best example I could give you of human engineering design would be a machine, the gravity wave telescope we showed you.
Right.
It can make measurements to 1 part in 10 to the 23. An amazing machine, but it ranks 10 trillion times inferior to the level of the design and engineering achievement that we see in our best example. So it shows you that the creator God of the Bible, the one that created the universe, must be at least 10 trillion, etc. times more intelligent, more knowledgeable, more creative, and more powerful than we human beings. Therefore, a personal being responsible for it.
Responsible. Someone who cared, was interested in this whole thing.
Well, we're going to talk a little more about this in our final episode of Journey Toward Creation. We encourage you to join us next week, as we'll get you all the way back to the creation event itself and the Creator. So thank you for your comments, and thank you for watching this show, and we'd love to hear from you. Welcome to Reasons to Believe, the television program where we look at the latest evidences on the frontiers of scientific research, latest evidences for Christ as Creator, Lord, and Savior, and for the accuracy and reliability of the words of the Bible. And we're not saying that the traditional reasons are necessarily bad. We think they're very good, but we just notice that many people, especially those outside the church, really appreciate how the new reasons show them things about God that help them to understand the traditional reasons. And we really do appreciate the feedback we get from all of you that watch this show. It helps us to structure new programs we'll be doing in the future, helps us to improve what we're doing. And Dave, you got a letter from our mailbox that helps us along those lines.
Yes, we got another one from a foreign country again today. This is from a Pastor Martin, who is in Kenya, East Africa, and he says, "You may wonder how I came to know you, but through my television you have come to be one of those that I really love. This is because through TBN, having been watching you keenly and discussing the issues about reasons to believe, your discussions, especially of Psalms 104, has been a real blessing to my wife and to I. Hoping to hear from you soon and remain in your ministry there. God bless you, Pastor Martin."
Well, that's a great comment, because we did do a series of shows on Psalm 104. And by the way, if you want to catch those, they are archived on our reasons.org website. But that whole series was developed as a result of people like you writing in and saying, we'd like to see you address some of the other creation accounts in the Bible. And we may be getting to some of the other creation accounts, but Psalm 104 is the first that we took on.
Yeah, that's a very powerful account.
A really great way to understand what Genesis 1 is talking about.
Such a strong parallel between the way it's divided up and the days there given in Genesis chapter 1. So it's a very good account.
Well, what we want to do today is to complete our journey toward creation. This is the documentary that we've developed for television and for video that takes you on a simulated journey from the surface of planet Earth all the way out to the very limits of the cosmos. And now, thanks to technology, we can see so far back in time, we can even directly photograph that moment when light first separated from darkness in the history of the universe. And as we saw in our last episode, we can get even earlier than that, thanks to some incredible technology that's just been brought online. So what we want to do today is to finish this journey for you. And the whole concept here is that the farther you look out into space, the farther back in time you see, the closer you get to the creation event, and the greater the accumulation of evidence that the Creator God of the Bible is the one that created the universe and structured it for our purpose and our benefit. So here is the last of the 6 episodes.
The study of the cosmos can be compared with the backward running of a fireworks video. As we measure and observe the cosmos closer and closer to the first moment of its existence, we are running the tape backward toward the moment of creation. As we draw closer still to the creation event, we observe the universe becoming hotter and hotter. Eventually, in this backward replay, the universe will be so hot that protons and neutrons can't stick together. All atomic nuclei fall apart. At this point, we're just 3 minutes away from the creation event, less than 1/10 of a millionth of an inch from the Empire State Building, just a few molecules away from its base. Let's push on. As we probe even earlier, we encounter a blinding flash, just 1 millisecond from the creation event. This flash is generated by the sudden annihilation of all antimatter in the universe. A delicate balance of 1,000,000,001 particles to every billion antiparticles guarantees the existence of matter in the later universe, and it also guarantees the possibility of life. Pushing back to just a few dozen microseconds from the creation event, protons, neutrons, antiprotons, antineutrons decompose into even more fundamental particles called quarks. At 1/10,000,000,000th of a second from the creation event, the universe is too hot and too dense even for quarks to exist. At 100 billionth of a trillionth of a second from creation, the universe is too compressed for light to be possible. The universe is now completely dark and smaller than a single atom. All we see at this proximity to the creation event are the shrinking dimensions of length, width, height, and time. That is, until we reach a speck of time, just a 10 millionth of a trillionth of a trillionth of a trillionth of a second from creation. Before this moment, all 10 dimensions of the universe began to expand. After this instant, only 4 dimensions continue to expand. So what has happened to the other 6 spatial dimensions? They remain tightly curled up, smaller than 1 billionth of a trillionth of a trillionth of an inch, around our dimensions of length, width, height, and time. These other 6 dimensions still exist, but with no possibility of uncurling. Let's dare to roll back the film the rest of the way. The universe continues to shrink, the 10 dimensions growing smaller and smaller. At the creation threshold itself, often referred to as the Big Bang, all 10 dimensions become infinitely or near infinitely small and suddenly disappear. And it is from this infinitely small beginning that the entire universe sprang forth, in every aspect, from the formation of planets, galaxies, stars, to the relationship between the mass energy and the space energy density, and even the laws of physics themselves must have been carefully fine-tuned from the creation event in order to make life possible for this brief moment in cosmic history on our tiny blue dot. But some might still argue that the Earth is not really all that special. If we believe the Earth is unique, some might argue that we're in danger of going back to ancient times, when the Greek mathematician Ptolemy popularized the idea that the Earth is at the physical center of the universe. This geocentric view dominated Western thought until the late 16th century, when Copernicus revived an alternative scenario that the planets orbit around the sun. Then Galileo peered through his telescope and rocked the world with observational evidence that Copernicus was right. This Copernican revolution describes a modern mindset that Earth is mediocre, just one tiny planet in a vast cosmic sea, and that the potential for finding many Earth-like planets is out there just waiting for discovery. But the more astronomers learn about the universe, the more evidence they find that the conditions necessary for life are far more numerous and far more narrow than anyone imagined. During our journey back in time, we have explored just a few of the over 200 finely tuned characteristics needed in order for any life to exist on any planet. This idea, known in astronomical circles as the anthropic principle, demonstrates that the universe has been crafted for the benefit of man. Religious, agnostic, and even atheistic astronomers use the anthropic principle as the foundation for their research of our vast cosmos. Increased understanding of the anthropic principle seems to be causing a new kind of revolution in the astronomical community. In one sense, Ptolemy's idea of geocentrism doesn't seem so silly after all. While Earth certainly isn't at the geographic center of the universe, it does seem to be at the biological center. Far from being a common, mediocre, rocky planet, Earth seems exceptional in every way. So what are we to make of all the observations that the entire universe appears to have been meticulously designed for humans? You could just say, what a coincidence, or it's just chance. But most astronomers don't seem to find those answers very satisfying. The fingerprints of intentionality and purpose are unmistakable. And here we confront the cause of the universe, what some astrophysicists call the entity. Listen to what a few prominent scientists have said about the origin of the universe. Physicist Paul Davies has moved from promoting atheism to conceding that the laws of physics seem themselves to be the product of exceedingly ingenious design. He further testifies, "There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming." And astronomer George Greenstein, in his book, The Symbiotic Universe, expressed these thoughts. As we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Was it God who stepped in and so providentially crafted the cosmos for our benefit? Or consider the words of theoretical physicist Tony Rothman. When confronted with the order and beauty of the universe and the strange coincidences of nature, it's very tempting to take the leap of faith from science into religion. And then there are the words of Arnold Penzias, who shared the Nobel Prize in Physics for the discovery of the cosmic background radiation. Astronomy leads us to a unique event, a universe which was created out of nothing, one with a very delicate balance needed to provide exactly the conditions required to permit life, and one which has an underlying, one might say, supernatural plan. Finally, as Stephen Hawking concedes, it would be very difficult to explain why the universe should have begun in just this way, except as the act of a God who intended to create beings like us. The entity that brought the universe into existence must be the master of all space, time, matter, and energy. This entity must be powerful enough to create space-time dimensions at will, and to exquisitely fine-tune an untold number of cosmic characteristics. More than 200 have been uncovered so far. The probability of all these known parameters randomly coming together would be 1 chance in 10 to the 215th power. A probability so incredibly tiny that statistically speaking, it's impossible. And this probability is becoming even more remote with every new scientific discovery. Such a high degree of design demonstrates that this entity must be a personal being with an amazing creativity, wisdom, power, care, and love to a degree far beyond human capabilities. He has fine-tuned the Milky Way galaxy, the solar system, and planet Earth so its spiritual life can be fused with physical life in this one small place for one brief span on our timeline. More than an accident, more than a random sequence of events, we are passengers on a controlled and purposeful explosion. Our journey toward creation has provided us with an opportunity to gain a glimpse of the Creator's power and provision. But can we know who the Creator is? If this Creator is revealed through any or all of the world's religions, then it seems reasonable that this revelation would not contradict what He has revealed in the record of nature, science, and the world around us. Whether you are a religious person or not, I invite you to put your worldview to the test. Discover for yourself if it describes His glorious creation in a way that is consistent with what we've observed on our journey toward creation. Well, that was the final of our 6 episodes showing you this journey from the surface of the earth to the very limits of the universe itself. And now when you finally get to the end of that journey, you really are confronted with the Creator God of the Bible. In fact, we've actually done a little clip add-on where we look at this journey in the context of the world's great religions and see how it comports.
That's present in the video.
Right. And you really are able to discern that this journey really eliminates all possibilities but the God that we receive revealed in the pages of the Bible. This isn't Hinduism or Buddhism or Islam or animism or Darwinism. This is Christianity. Well, Dave, this last few minutes that we got to see are really quite remarkable.
It really is. It's the ability to be able to determine these things. I think, as you said at the beginning, the instruments that we now have, which are not ultimately not telescopes, but it's the theoretical understanding that we have, the general theory of relativity, and then, of course, the models that we can build and explore in the supercomputers that are available, and then tying that together with the research that's going on using particle accelerators and things of that nature. It's able to give us this kind of information, and it's just amazing.
And it's not nearly as model dependent as what some people might think. I mean, these particle accelerators that we've been funding, U.S. taxpayer funding, and the Europeans have been funding
as well,
actually enable us to check the conditions of the early universe. What they're doing inside these particle accelerators is duplicating the temperature and density conditions that must have existed when the universe was that young. And by that means, we can directly duplicate the conditions all the way back to when the universe was only a millionth of a trillionth of a second past the creation event. And that is enough to establish, for example, part of the unified field theory. I mean, this whole last few minutes we showed you here is really looking so far back in time where you see the 4 fundamental forces of physics step by step unify into one cosmic force. And we actually have the particle accelerators to verify the unification of the electromagnetic force,
certain of
with
the early ones.
Weak nuclear force, and a good chunk of what is necessary to get to the unification of the strong nuclear force with the weak nuclear force. And that really establishes that the model you saw there, Deanne, is a reliable model, and therefore really does confront you with the evidence that it's the Creator God of the Bible that brought this all into existence. And you know, that segment where I gave those quotes from different astronomers and physicists, I think it's important to emphasize that that really is ubiquitous. You know, in a book I wrote a number of years ago, The Creator and the Cosmos, we just put out a new update, the third edition. But in there I have a chapter that's devoted to just quoting from physicists and astronomers who do research in this discipline. And the thing I want to emphasize is I don't know of a single astronomer or physicist that has done research on the characteristics necessary, cosmic characteristics necessary for life, that does not concur with the gentleman that we quoted. For example, Paul Davies, the evidence for design is overwhelming. Everyone who's done research in this discipline winds up agreeing with Paul Davies.
Right, with that statement. Of course, we have to be fair and point out that they aren't necessarily coming to the same conclusion that we are. They're they acknowledge the design. The ultimate question is, where does this design come from?
Right, and you know, in that chapter, I was careful to predominantly quote from the non-Christians in the field rather than the Christians. And just to show you that even non-Christians are concurring that there is this design. But you're right, they're not necessarily agreeing with us that the designer is Jesus Christ.
Correct.
But they do recognize there's this overwhelming evidence for design, and therefore some kind of cosmic designer. Now, as to why our peers in physics and astronomy are not all agreeing with us that it's Jesus Christ, I primarily chalk that up to theological naivete. I mean, I went through the physics and astronomy programs at different universities in Canada. Not once was I required to take a course in theology. And therefore, most physicists simply don't have enough philosophical or theological background to realize that when they established that this agent that brought the universe into existence transcends matter, energy, space, and time, that this agent created matter, energy, space, and time, and he created the universe, and that this agent is trillions and trillions and trillions, etc., of times, provably more intelligent, more knowledgeable, more creative, more caring, more loving, and powerful than we are, that really does narrow you down to the Creator God of the Bible. Although I think I should add one more caveat. I'm not claiming that we have reasons to believe have proven that Jesus Christ is behind all this, but it's Jesus Christ plus or minus a scientifically measured error bar. And the error bar is now small enough to eliminate the competition.
And getting smaller.
And it's getting smaller. I think that's a critical point. That the conclusion that we present in this Journey Toward Creation documentary is something that can be put to even more rigorous testing. As astronomers continue to learn more about the universe, if we're right and the non-Christians are wrong, then the evidence for the supernatural design should decrease.
I would think so.
And the number of characteristics reviewing design would decrease.
That's, of course, the claim that is being made of scientists over the years is that, you know, in the past people used to attribute so much to God and to supernatural causes, and science has, over the years, I'm talking about, say, the last 100 to 200 years, science has shown that many things that we attributed to God have naturalistic explanations.
Right.
But that whole process has now been reversed.
Correct.
And the more we examine life and the more we examine astronomy, the cosmos, the more the evidence is growing that supports supernatural design. Just the reverse of what the tendency has been in the past.
Right. And so we would expect that that would continue. I mean, I'm confident that we're right, Dave, and therefore I would anticipate in the next 30 days, 90 days, 2 years, 10 years, that we'll have an even stronger case.
That's right.
And that's really one of the reasons we went to the trouble to produce a second edition. Because just in the last 5 years, the case has become so much more powerful for the Creator God of the Bible than it was 5 years ago, that we just wanted people to see how much stronger that evidence has become. Not to mention the fact that we can present it in a more beautiful fashion because we've got many more
Right.
images to show people.
Now, we did a television series here. I think the last series that we did was on the anthropic principle,
Right.
which was discussing, without all of these nice graphics, many of these same principles, and
Right.
shown how the evidence is growing continuously to support the idea of this transcendent creator.
Well, in that sense, we at Reasons to Believe are prepared to stick our neck out. We're making a prediction that if you give us a couple more months or a couple more years, the evidence will get even stronger than it is today. And those who are non-Christians are convinced they're right, then they should see the evidence for a case getting weaker. So this is something where we can put things to the test. And one of the things I hope to achieve with this video, Dave, is to put aside all these fights that people have over creation evolution. This is the one arena in the creation evolution debate where it's easiest to put things to the test. And so my appeal to all of you that are watching is there's no need to fight over creation evolution ever again, or to fight over whether the Christian worldview is right as opposed to other worldviews. We've made our predictions. We're prepared to stand by them. If our predictions come true, then believe in Jesus Christ as Creator, Lord, and Savior. If our predictions prove false, then that will establish that our belief in the Bible and Jesus Christ as our Creator and Savior is misplaced. And so I just offer that as a challenge to everybody. No need to get into a dispute. Let's just see what happens as scientists in different disciplines learn more and more about the universe and life and the earth. And time will tell, and it doesn't have to be a long time. Every day, new discoveries are being made that help us put to the test the Creator God of the Bible and our testable creation model. So I encourage all of you to share this video with your friends and neighbors, and to gently encourage them to really consider the truth claims that we see written on the record of nature and the universe, as well as in the words of the Bible. We appreciate your comments. Let us know how this tool works for you as you share with your friends. Thank you.